Okay, so doing 9.4, number 55. How do we start this? Oh yeah, I should probably look at the exponents. All the exponents in this problem are negative, right? So I should rewrite them all as 1 over the kind of respective stuff, right? So let's see. X to the minus 1 is 1 over x. Okay, what's y to the minus 2? 1 over y squared, right? Okay, then I'm adding 1 over x squared times 1 over y. And then all of this stuff is over 1 over y squared plus 1 over, yeah, it's still minus. Okay, good. All right, now what do I do with this? Top first? Top first? Yeah, we can try that. Okay. Bottom first? Common bottom. There we go. So, yeah, so where are the parentheses? So there's parentheses here, right, saying we should do the multiplication first. But there's maybe bigger parentheses around this whole top, right, and around the whole bottom. So maybe first we would work with the top, right? What's up?
When you do like double parentheses, do you have to do like the square one inside of the circle ones, or can you do like double?
I pretty often do double round ones. Your calculator doesn't even have a button for square ones, right? It really doesn't matter. It's the reason we do kind of different styles of parentheses at different depths is just so we can tell them apart. You can really pick whatever style of parentheses suits you. They do make a difference in interval notation, right? When we're writing an interval down, the square bracket means a different thing than the round bracket. But at this level where I'm grouping symbols, it doesn't matter. Okay, so maybe I want to start with, I don't know, the top or the bottom.
Wait, don't you have to flip them over?
I can't. So I would like to say that's the top divided by the bottom, right? And then flip over the second half. But the second half's not a fraction, so I can't flip it over. It's a sum of fractions, so I have to make it a fraction first. Does that make sense? Okay, so how do I maybe make the bottom or the top into a more reasonable thing for me to use? Yeah, I gotta find a common bottom, right? So let me work with the top. So the top is 1 over xy squared plus 1 over x squared y. Right, that's just like this. Okay, so what's the common bottom here? So the common bottom is x squared y squared. I think that's good. All right. So what does this one need? That one needs, to get to the common bottom, right? This is a x y squared. To get to x squared y squared, I need a x. You guys see that? So I should multiply top and bottom by x, right? So I should do, all right, I've got 1 over x y squared. I'm going to multiply the top by x, multiply the bottom by x. Good, and this one I need a y on top and bottom. And that makes this whole thing into x over x squared y squared plus
1y over,
yeah, 1y, which is y, right, over x squared y squared. Now these have the same bottom, right? So I can add them. So I get x plus y over
x squared y squared.
or x squared y squared. Cool.
Just a minute here. And that's for
I'm having a hard time seeing the common denominator. Can we go again?
Yeah, so looking at the common denominator here, I'm thinking, all right,
How did you get it from X?
yeah. So this one,
Oh.
right, is an x times a y times a y, right? This one is a x times a x times a y. So when I think, okay, what do I need to have these in common, right? This one's got an x, that one's got an x, right? So I'm okay with one x. Oh, but this one doesn't have a second x, and that one does. So this one's going to need another x. Then the same is true for the y's in the other direction, right? So really that's saying, okay, what have I got here? I've got two x's in one of them, so I'll need two x's in my common bottom. And then one of them has two y's, so I'll need two y's in my common bottom. That's all I've got. So two x's and two y's. Helpful? Okay. All right, so this was just the top, right? Okay, so now we should do the bottom. So what's the bottom? Close. So yeah, so I'm thinking, okay, what's the common bottom here? This guy's got two y's, that one's got two x's, so my answer is going to have two y's and two x's, right? So my common bottom here is the same as my common bottom was before. Common bottom is x squared, y squared, right?
Wait, does it matter that they're not in order?
No, not at all. Right, multiplication doesn't care about order as long as it's all done at the same time. So let's see, here I've got a 1 over y squared, that needs a what?
X squared.
That needs an x squared, so x squared top and bottom. And then I've got minus 1 over x squared, what does that guy need?
Y squared.
That needs a y squared top and bottom. So I'll get x squared over
X squared, Y squared?
good, right? That's the common bottom I was shooting for, so it better be over that. What did I get in the second half?
Y squared.
I get a y squared over x squared, y squared, right? The common bottom. So all told here, I end up with x squared minus y squared over x squared, y squared. Right? Okay, now what? Blah, right? I was doing a thing about this fraction to begin with, and I've dealt with the top and the bottom. So this thing is the top. Right, here I'm thinking top. Divided by this guy. Why am I dividing by that guy? Because it's the bottom, right? Okay, so what do I do now?
Wait, did you just take that one, the bottom, is that what you were looking at?
Yeah, I was really thinking, right, back at the beginning here, I had a top divided by a bottom.
Okay.
So I fiddled around a little bit and I found an easier way to express the top and an easier way to express the bottom. So then I said, okay, well, my whole fraction was just the top divided by the bottom. So this guy better be top divided by bottom.
Oh, okay.
Cool. All right. So now what?
We want to flip.
Good. Cool. We should flip and multiply, right? So let's see. I've got an x plus y over x squared y squared times.
X squared, Y squared.
Good, guys. Very good. Over.
X squared minus.
Thanks for jumping ahead there. Yeah, that's the difference of squares, right?
Right.
You guys see that? Okay, so let's see. What can I cancel at this step before I play with difference of squares?
The x squared, y squared.
Yeah, I can cancel a x squared with an x squared and a
Y squared.
y squared and a y squared, right? Cool. All right. Okay, so now what?
X plus y over x plus y over x minus y.
Very nice. Okay, now what can I cancel?
X plus y.
Pluses.
The pluses, yeah, I can cancel an x plus y and an x plus y. And what does this leave me with? 1 over x minus y. How many of you wanted to put the x minus y on the top? Okay, a few of you. Don't do that, right?
Right.
Why not? No, that'll make it 1 on the bottom anyway, but it's a good thought, Jennifer. So why can't I put the x minus y on the top?
So you changed the whole number.
Yeah, I was dividing by it originally, right? So I will have changed the whole number. You guys see that? So careful, careful. Make sure when you cancel all the stuff that things, if you cancel all of the stuff in one place or the other, right, top or bottom, that you get the appropriate thing out. Right, so because we were doing multiplicative canceling here, right? We got 1 on the top. If we had done an additive cancel on the top, right, where we had an x minus x or something, what would we end up with? Yeah, we'd end up with 0. You guys see how those are different? Okay. Cool. Other questions on this one?